So, uh, rather than working on with separate plots, we worked on with line plot, we worked on with multiple line plot, we worked on with scatter plot. In that way, there are multiple different kinds of plots also. Let's see what are the other different kinds of plots that we are having. So I'm just muting all because I'm just getting a small sort of disturbance from you side. So suppose, so as we have already done line, scatter, multiple line, we are doing bubble plot. Suppose x is equal to, I consider 10, 20, 30, 40, 50. See, bubble plot is also similar to scatter plot only, but the size of each and every scatter varies. So 20, 35, 25, 45, and 40. So for this, let me give the size. Size is equal to, I consider 100, 300, 500, 700, 1000. So PLT dot scatter x comma y comma s is equal to size comma alpha is equal to 0.6. PLT dot x label x axis y label as y axis. PLT dot title bubble plot. PLT dot show. You can see each and every bubble separately. So let me just. So each and every bubble has different size. So the next one is bar plot. So here I consider subjects is equal to Python, machine learning, deep learning, Gen AI. Four things I am considering. Marks is equal to, I consider 90, 98, 76, 80. PLT dot bar S comma marks. So I'm not giving X label, Y label, and title. I'm just keeping PLT dot show. Suppose if you want horizontal bar, the same thing bar H, it converts to the horizontal. Next, grouped bar. This is horizontal bar. Next one is grouped bar. When considering the grouped bar, again I consider students is equal to A, B, C, D. Four categories. For these A, B, C, D students, I'm giving the Python marks as 80, 90, 70, and 85. Similarly, ML marks. I'm giving 75, 85, 95, 90. Now I consider X is equal to NP dot A range, array range, length of students. So for each and everything, grouped bar or we call, I consider width for each and every bar. I consider 0.35. PLT dot bar. X minus whatever X values which you are considering, that means arrange minus width, whatever width was there, divided by 2. So I have to consider this Python marks, comma, width, comma, label should be Python. Similarly, label is ML. So here, as you are having multiple different things, you for your understanding, you should give the ticks also. Ticks X comma students. So you have to give X label, Y label, title, and you're having multiple things, then you should actually give legend also, plt dot show. So in one, you have two things that are carried. So if you want two separately, you want, then you have to give staked bar. Grouped bar is one above other, you can see. But when coming to the staked bar, generally grouped bar, as there is a disadvantage that you can't see what happens at the back end and all, you use the staked bar. So plt dot bar students, comma, Python, comma, label should be Python, and plt dot bar considering the students, comma, machine learning, comma, bottom is equal to Python. That means at the down part, you should have Python. Label is equal to, you should have machine learning as the label for this. So, depending upon, suppose if you consider this 80 plus 75, how many marks? 155. Till 155, there will be the raise. So depending upon the total of this two, there will be raise. Depending upon bottom, it should be Python. So Python marks reaches the bottom, then value added with the above marks. Suppose if I say the graph raises and falls as per this particular marks only. Depending upon the marks, there would be rise and fall. Okay. Next one is histogram. When coming to the histogram, let me consider some marks. In generally, suppose there are some around some 10 to 15 students in the class, I am considering marks of all the students. That means average marks of all the students, for suppose 50, 60, 60, 60, 70, 70, 45, 70, 80, 90, 98, 98, 95. if this is the thing, these are group of marks, plt.hist, considering the marks, comma, bins is equal to 5, comma, edge color is equal to black. So plt dot show. See, for any of the thing, you can just go on with X label, Y label, and title would be common. I am not doing as they are common. I am not keeping it for all the things here. This is the histogram. Clear? Next, multiple histograms. So as I'm taking Python, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. So plt dot histogram considering the marks of Python, bins is 5. I can consider alpha is equal to 0.5, comma, edge color is black, comma, label is equal to Python. Similarly, considering ML marks. ML. So X label, Y label. When you are having multiple things, you should add plt.legend. Multiple histograms. Next. Box plot. I consider marks is equal to plt dot box plot considering the marks. So X label, Y label show. This is the box plot which you have. Suppose if I have one value as 900 is very big. Let me consider 300. You have the round. That means this is the out layer. Suppose I consider 200. 200 also will be the outlier only. Next, multiple box plot. When coming to the multiple box plots, here also I give so here plt dot box plot. I wanted to draw the box plot for Python, machine learning, deep learning. Now I say plt dot xticks 1, 2, 3, comma Python, ML, deep learning. plt.show. You can see multiple box plots. See, customizations of this we will see in the next class. Only the thing is I'm just showing you different kinds of plots. Next one is a violin plot. So in place of box, I just change this to violin. In place of box plot, you can see the violin plot. So depending upon the values, you can have the change in the graph. Where the number of values are more, that actually gives you the bulge, up and down bulge will be there. Next, pie chart. Suppose I say I have this subjects as I have the subjects or else hours, 30 hours, 25 hours, 45 hours, 20 hours. PLT dot pie chart considering hours, comma, labels is equal to subjects. For this, always when you are drawing a pie chart, always you should make a mention of auto PCT. Auto PCT is basically auto percentage. The complete round should divide depending upon the marks. It should divide that thing into the auto percentage. How it divide the whole percentage should be 100%. After point, I want one float value, percentile. So PLT dot show. Labels. So you get this. So depending upon the value, it will calculate it in the percentage format and then gives you the output. So the next one is exploded pie chart. When coming to the exploded pie chart, the same thing. Here, I am just adding explode is equal to 0 0.1, 0, 0, 0. 4 things are there. I'm just exploding only 30 to explode. Remaining all I'm just considering like that only. Here you can just add explode is equal to explode. Generally, explode is basically come out. So the pie chart will come little out. Little amount, it will be little distracted from the original thing. That part will be shown in a separate way. Got it? Next, area plot. Suppose I consider x is equal to 1, 2, 3, 4, 5 and y is equal to 10, 15, 20, 30, 25. So I say PLT dot plot. I consider generally x, y. PLT dot fill underscore between x, y. PLT dot show. This is the area plot. The next one is staked area plot. I consider months is equal to, I consider Jan, Feb, March, April, May, June, July, 1, 2, 3, 4, 5, 6, 7, August, September, October. I say PLT dot stack plot. Months, Python, machine learning, deep learning. Labels is equal to Python, machine learning, deep learning. PLT dot legend. When you always have group of things, you should give the legend. PLT dot show. As you are having multiple different things, you are having multiple different staked area plot. Next one is stem plot. In place of plot, just change this to stem. So for a line, you would be getting stems for each and everything. The next one is step plot. In place of stem, you just change this to step. You would be getting like steps. Next one is error bar plot. I consider x, y values and I consider error values also. Error is equal to 2, 3, 1, 4, 2. I'm just giving some error values. PLT dot error bar considering x comma y comma y error is equal to error values that we give fmt is equal to O. So wherever you are getting fmt is basically the notation. Annotation you would be getting as O. So wherever the value was there, the value over here is mentioned like that. So here the values are error is this much error. So up and down 2, it will raise 3, 4, depending upon the error is the line that you get. Okay, this is the error bar. The next one is heat map. Data is equal to, till now I didn't take any of the random data. So here I'm considering random data. Random dot rand 10 comma 10. PLT dot IM show, image show, considering the data. PLT dot color bar. I think we have already done the color bar. PLT dot show. You get the color bar. In this, we have done multiple different shades also. The next one is matrix plot. So matrix is equal to np dot array 1 2 3 4 5 6 7 8 9. PLT dot mat show matrix. PLT dot, even for this also we give color bar only. PLT dot show. So matrix. So this is one matrix, this is one matrix, and 3 by 3 matrix you are getting multiple different colors for each and everything. PLT dot T color, considering the data. PLT dot color bar. PLT dot title of this plot will be P color. So for all the things at last you have to give show. So P color plot. Next P color mesh. The same thing I'm considering after you considering the random data. So here rather than P color we give mesh. P color mesh. The same plot you would be getting, but two different ways of writing it. The next one is generally the three-dimensional data. If you wanted to consider in two-dimensional, then we use this one. Generally, we won't use in real time, but still this is also a plot that is available. Contour plot. X is equal to np dot line space. From -5 till 5, consider some 100 values. Similarly for y, x comma y is equal to np dot mesh grid, considering x comma y values. Z, that means the z-axis would be x square plus y square values. PLT dot contour x comma y comma z. PLT dot title, contour plot, plt dot show. Contour. Suppose if you wanted to get a filled contour, contour F, just adding F, you get the contour filled. Next one, hex bin plot. X is equal to np dot random dot rand n. Consider some 5000 values for X and 5000 values for Y. PLT dot hex bin X comma Y comma grid size is equal to some 30. PLT dot color bar you get everything in the histogram over here. Suppose if I just change the grid size to 90, it get more minimal, small, 10, you get little big. The grid size decreases, the bin size increases. Similarly, hist 2D plot. So in place of hex bin, I give hist 2D. So in place of grid size, I give number of bins. See here, there are no more, I mean to say hexagon shape, all are squares only. This is hist 2D, two-dimensional histograms. See, we can draw some good amount of 3D plots also, but generally we won't work on with the 3D data, but for your understanding, I'll just show you how do you do that. AX is equal to figure dot add underscore subplot. One row, one column, and one axis should be increased. Projection is equal to 3D. X is equal to 1, 2, 3, 4, 5. Y is equal to 2, 4, 1, 5, 3. Z is equal to 5, 3, 4, 2, 4, 6. AX dot plot 3D X, Y, Z PLT dot show. You get the 3D plot. See, not only like this, only the line we do. We can even do scatter 3D. You get the scatter plot also. Like a contour, if I take this, capital X, comma, capital Y, comma, capital Z. You get the surface plot. If the same thing, mm, plot wireframe. You get the wireframe, the mesh kind of a things you get. This is the contour plot. So multiple different 3D plots also we can draw. But generally we won't work on the three-dimensional plots. So these are the different styles of a plots we have. So why we won't work on with the 3D plot is generally the data which you consider in real time are always a two-dimensional data. That means only rows and columns will be there. You won't have the z-axis. That is the reason we work only on with the two-dimensional plots. So all the two-dimensional plots, we have just seen what are the different kinds of plots we have. So we will be looking after different customizations on the plots in